Alright, we're talking about tessellations. This is section 7.4 in your book if you want to go back and review there. Okay, the first thing you need to write down is what a tessellation is. A tessellation is an image of shapes, okay, polygons, that completely cover a plane with no gaps. Okay, a tessellation that uses only one shape is called monohedral. Okay, so that would be mono, because mono means one, hedral. Okay, so only one shape is monohedral. A monohedral tessellation consisting of congruent regular polygons is called a regular tessellation. Okay, in geometry, when you hear that word regular, if you want to make note of this, regular means all sides are equal, all angles are equal. Okay, so in your triangles, it would be an equilateral triangle. All three angles 60 degrees. Quadrilaterals, it would be squares. Okay, all four angles 90 degrees, all sides equal. Okay, you can have regular polygons of any number of sides, but if you notice down here, when you have regular triangles or equilateral triangles, they all meet up with no gap to create a circle. Okay, it's a 360 degrees. Okay, when you add up the corners of a square, these are 90, 90, 90, 90. Again, that's a full circle, 360 degrees. For a pentagon, that's a five-sided figure, you can't fit four together, they would overlap, and three together does not make a full circle. Okay, so that one you cannot use to make a monohedral tessellation because there would be a gap. Hexagons, six-sided figures, okay, all three angles added together, no gaps, makes a full circle of 360 degrees. Okay, that's because in a regular hexagon, each of these angles is 120. In a square, they're each 90. In these triangles, they are each 60. Okay, so the only shapes that can make monohedral tessellations are triangles, squares, and hexagons. You can have tessellations that are made up of more than one polygon, and those are no longer monohedral though. Okay, so here's a picture, just an example of a tessellation that has two shapes. This is using squares and octagons. Okay, so what this is called vertex arrangement here, this is looking at the vertex or the corners where your shapes meet. So you can pick any vertex, so I'm going to pick this corner right here, and what is comprised right there, what shapes make up that vertex? Okay, that is the corner of an octagon, and a square. Okay, an octagon is 8 sides, so that's 8, 8, and a square is 4. Okay, so this would be called its vertex arrangement, 8, 8, 4. If you have two of the same one in a row, instead of 8, 8, you could say 8 squared, and then the 4. So either one of these would be the correct vertex arrangement or numerical name of this tessellation. Okay, when you have tessellations that have the same combinations of regular polygons, okay, and all of the vertices meet in the same order, every single vertex is the same order, okay, that is called a semi-regular tessellation. Okay, it's regular because it's the same pattern over and over again, but it's more than one shape, so it's semi-regular. Okay, in these two examples of semi-regular tessellations, you can see you can pick any vertex. So if I pick this vertex here, okay, this is a decagon, a hexagon, and then a square. So decagon, hexagon, square. Okay, if I pick any other vertex, it's a decagon, a hexagon, and a square. Any other one, say this one here. This is a decagon, a hexagon, and a square. Okay, so they are all of the vertices are made up those same three shapes. Okay, in example 2, these are decagons and triangles making up this tessellation. Okay, so here you have, let me see, is this a decagon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is a dodecagon. So it's a 12-sided figure and triangles. So this dodecagon and triangles. So here at this vertex is a dodecagon, and a triangle. So that's 12, 12, 3. And again, when you have two of the same, you can write 12 squared, 3. Okay, so those would be the vertex arrangement or numerical name of that figure. Sometimes you'll have tessellations that have different vertex arrangements at different vertices. So these two examples point that out. So at this vertex, okay, if you notice at this intersection, there's a triangle, a square, a triangle, a dodecagon. So 3, 4, 3, 12. Okay, and then at this intersection, at this vertex, it's just a triangle, a dodecagon, a dodecagon. So 3, 12, 12. There's no square there. Okay, so these at any of the vertices you choose would be one of these two. That's called a 2 uniform tessellation because it's not semi-regular. They're not all the same. Okay, there's 2 different vertex arrangements. So that's 2 uniform, and you can also have 3 uniform. There's 3 different possible vertex arrangements. Okay, so that's pretty much what you need to know about tessellations to do your project. You need to come up with your image, whatever tessellation you want your design to be, and you'll trace the shapes. I have the shapes for you to cut out, and you'll trace that same image over and over and over onto your grid paper. Here are just some other ideas that you may want to use. These are all in your book in section 7.4. Okay, notice in this picture they use just triangles and squares, but they used 4 different colors, so it gives it a different pattern. So that looks pretty cool, even though you're only using 2 shapes. Okay, this one uses 3 shapes. You have your dodecagon, triangles, and squares. So this is 3 different shapes, and they use 4 different colors. So you can use more colors than you have shapes to create your pattern. This one is only triangles and squares. This one is only triangles and squares, yet they look different because of the way that they colored them and arranged them. These put 2 squares together with triangles around them. This is 1 square with triangles around it. Okay, so different designs with the same shapes. Okay, this is 3 shapes. You have squares, triangles, and hexagons. And this one is 2 shapes. You have triangles and hexagons. Okay, and of course you can go back and look at any of these others. All of these images are from the book, even this one from the front cover page. That's pretty much it.